I think I'm live now. Hello everyone. So we are going to be absolving education code forces round 108 today. Can people in the chat let me know if my audio is clear and everything? Okay. Okay. I think yeah, perfect. I can see there are many comments. Say okay. I think I'm live. Every clear. Okay. Audio is also clear. Okay. Perfect. I would like to know in the chat how many people were able to solve A, B, C, and A, B, C, D. The count of the problems that you are able to solve. Let's see how many. Okay, so A, B, and D. Okay, that's nice. What about C, Abhishek? Okay, I'll just pass over the problems. Okay, cool. I think we should start now without wasting any time. So let's come on to problem A first. So the problem says that you have R red and B blue beans. You'd like to distribute them among several packets in such a way that each packet has at least one red bean, has at least one blue bean. The number of red and blue beans should differ in no more than D. Okay, I tried Lapindro's problem on code check and that too bad. I am not sure, Gautam, what problem you are talking about, but yes, n to the power 12 actually depends on n. Aman Joshi gave my first Codeforces contest, solved 0. That's okay, Aman, I think. Like, I remember in my first Codeforces contest, I also solved 0 problems. Okay, Hitesh said second contest, A and B. That's good, Hitesh, I would say. Okay, cool. So let's look at this problem. So basically, we are given R, we are given B, and we are given D. So the thing that we have to do is we actually have to distribute these values into different packets. Let's say this had R1, this had, and this had B1, this had R2, this had B2. So what they want is the absolute difference, that is R1 minus B1 should be less than equal to D, and same for this as well, R2 minus B2 should be less than equal to D. Okay, cool. So the thing that we have to do is, so let's just talk about, let's say we have a minimum, let's for instance assume that R is less than B. Now if R is less than B, that actually tells us that in every packet we'll either have more count of B than R, or we'll have equal values. We'll never have, like, we can have lesser values, but to solve this in the most optimal way, there is no point of having B less than R. So let's say if R is less than B, then in every packet we're actually going to put more blue balls than red balls. So let's see if we had one, this is the count of red balls and this is the count of blue balls. So let's see how many balls can we put in one packet if we had one red ball. So if we had one red ball, we can actually put D plus 1, because the difference between this comes out to be D, and that is the desired difference. Now let's say we put one more red ball in other packet, we can again put D plus 1 balls. This actually also gives a difference of D. So with this you can actually say that if we have R number of balls, then B should be less than B times D plus 1. Here we are considering that R is less than B. So that is all you have to check. If R is less than B, you just have to check if R is actually, sorry, if B is actually less than equal to B times D plus 1, because that is the maximum number of balls we can adjust when we have R number of balls. And similar for the other way around as well. Let's say if we had B is less than R, then R should have been less than equal to r times d plus 1. I hope that's understood to everybody. If anybody has any issues, they can let me know in the chat. Okay. So the thing we are actually now, we don't really need to even care about if r is less than b or b is less than r. We can just have a minimum value, which will be actually minimum of r comma b, and we can have a maximum value, which will be maximum of r comma b, and then we can just check if maximum is less than equal to minimum times b plus 1. That's all. That is all you have to do. So let's code this up very fast. Okay, let's have a editor here. So in the first problem, the inputs are actually, we have t number of test cases. Then for every test case, we have three values that are r, b and d. So we have r, b and d. Now let's say we have a variable of min that actually stores the minimum of r comma b. Then we have a value maxi that actually stores the maximum of r comma b. So now what do we have to do? So if maxi is less than equal to many times d plus 1, then we can just say that the answer is yes. Okay. Else we can say that the answer is no. Let's run this. Okay, so let me just readjust a few things. So as you can see, we have the correct answer for the first input. Let's submit it. Okay, let's come on to B.
Wrong answer on test 2.
Okay, so Yashashvi says, how do we are assuming we are putting r equals to 1 each time? So we are not, so we actually have to look at the worst case complexities. Just a second, I think I did something wrong. Let's see that. Okay, so basically we are actually looking at the worst case complexities here. So if r is 1, then we can put d plus 1 balls of blue color. Then if r is, again, then this is one packet, then we have another packet, and likewise. Amazing, it was that easy. Okay, cool. I think I did something wrong. Just a second, let me just look at it. We have the correct r, b and d. We have r, b and d, minimum r, b. Can anybody tell me what silly mistake I'm doing here? Okay, cool, okay. We have these are smaller. Just a second. Okay, so we actually need long as well in this. So we'll just replace all these int with long. We'll have an int here. That is all. Okay, cool. Okay, we have accepted now. Okay, cool. So that was problem number 1. Let's move on to problem B. I hope problem A is clear to everybody. Okay, cool. And with that, I'll actually take a different color marker. Okay. Okay, let's move on to problem B now. So the problem says that there's an n into m grid. You're standing at cell 1 comma 1 and your goal is to finish at cell n comma m. You can move to the neighboring cells to the right or down. In one word, suppose you're standing at cell xy. You can move right to the cell x comma y plus 1. It costs x bubbles. Move down to the cell x plus 1 comma y. It costs y bubbles. Can you reach nm spending exactly k bubbles? Okay, so the problem says that, let's say we had a grid of n cross m. Okay, so okay, cool. Let's have something which is not equal. So let's have 5 cross 6 grid, and this is n, this is m, and the grid is actually of 5 cross 6, and we are standing at the very starting index, that is 1 comma 1. So let's see the amount. So this is 1 2 3 4 5, 3 4 5 and 6. So the problem says that, let's say if you're at this index and you try to move in the right direction, then this is going to cost you 2, because the exit coordinate of this is 2. So basically what you're trying to do is from x comma y, so basically from x comma y you're trying to go to x comma y plus 1, and this costs x value. And if you're trying to go from x comma y to x plus 1 comma y, then this costs y value. That is what we have in the equation. So if you're going from 2 comma 3 to 2 comma 4, it is going to cost you 2 whatever that is. And then if you're trying to go from 2 comma 3 to 3 comma 3, then this is going to cost you 3. Okay. Okay. Okay, Prashant says how you solve D. We'll come to D as well, Prashant. Okay. How to get coding and recursion. You will see that, Shiva. Prashant says, oh, hi, Prashant. Okay, cool. So let's see. So let's just take any two random directions and see what is the final amount coming. So let's first take, let's say we move like this and then like this. So this is one way, and let's have another way as well. So let's say the other way was this and this. Okay, cool. So let's count the amount that we need for moving from this path, and then let's count from this path as well. So for this path, you can actually see that we are actually going to the cost will be x equal to x. So this is going to cost us 1, this also 1, 1 and 1. So we have 1 plus 1 plus 1. Then now let's come here. So this is actually going to cost you 6, 6, 6 and 6. So this will be 6 plus 6 plus 6 plus 6. Now let's talk about the other path. So for the other path, this is 1. Now this is going to be 2. This again is going to be 2. Then this is going to be 3. This again is going to be 3. Then for this we have what? 4. For this we again have 4. And for this we have 5. And for this we again have 5. So this actually comes down to 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5. Now let's look at the sum of this. So this actually becomes 24 plus 4, that is 28. And let's count this. So this is 10, 18, 21, 24. This actually comes, so this is 1, this is 2, this is 2. Then we have 3, 3, 4, 4, 5 and 5. Okay, so this is actually 5, 8, 11. So this is 1, this is 1. Okay, so we actually missed 1 here. So this is plus 1 as well. This is 29. And this sum comes out to be 29 as well. So as you can see, even if we go from any path, the total sum remains the same. Now let's see what this total sum is. Let's fix this path. Now in this path, you can say that, so this was, if this was m, we actually had 1 times m minus 1, because we actually moved m minus 1 times, and for every move we actually had a cost of 1. So this is 1 times m minus 1, and while moving down we actually moved n minus 1 times. So we moved n minus 1 times, and the cost was equal to m. So the total cost comes out to be 1 times m minus 1 plus m times n minus 1. Let's solve this. So this becomes m minus 1 plus nm minus m. Now this m and this n get cancelled, and this comes out to be nm minus 1. That is the total amount that we need to pay from moving from 1 comma 1 to n comma n. That is all. So we just have to calculate nm minus 1 and see if this is equal to k. If this is equal to k, the answer is yes. Otherwise the answer is no. I hope it is clear to everybody now. Okay, so let's code this up very fast. Okay, so in this, what do we have? We have t, number of test cases. Okay, then we have, for t, every test case we have 3 values. We have n, m and k. And let's scan these values now. Okay, So what is our answer? Our answer is actually equals to n times m minus 1. Now we just have to check if answer equals to k. That means the answer is yes, else the answer is no. Cool. Let's compile this and see if this works. Okay, so let's try to submit this now. Okay, cool.
Accepted.
Okay, so as you can see, this is accepted as well. Okay, I hope problem B is also clear to everybody. If anybody has any issues, they can let me know in the chat. Okay, cost will always be same independent of path. Yes, exactly, Prashant. Rahul Gamwar says, can you please solve this problem using backtracking? Okay, so I'll just show you on the board like how backtracking is going to work. So we actually, okay, so, but I won't be writing the code because we just already know that the value is going to be same. Okay, okay, so this was the grid. This is not really backtracking as well. It's just like having a plain brute force. So when we're at this path, we know that, so let's say this is X and this is Y. So when we're actually moving up, we know that the cost for this is going to be X. For this, it is going to be Y. Then when we are coming up, this is going to be minus one, X minus 1. And when we move from in this direction, this is going to be Y minus 1. So if you look at this, the value at this particular path, it is going to be, from this path, it is X minus 1 plus Y. And for this path, it is Y minus 1 plus X. So this comes out to be X plus Y minus 1. And this comes out to be X plus Y minus 1 as well. And this is how we know that the value is going to be same. Now, instead of like finding out the complete value, that is nm minus 1, we can just have a brute force running from either from the top or from the bottom and just calculate the value for every cell and then check if the total value is equals to k. But I don't really think that is like there is use of doing that, since we actually know that the final value is going to be nm minus 1. Okay, Shrikanta says clear. Perfect. Okay. Okay, so let's come on to the third problem. Okay. Okay. So in third problem, polygraph. Okay, let's rub this. Okay. Hiten says my C got accepted. Now use long answer. Okay, so that is something I would say many people make that mistake, but whenever you get a wrong answer, you should always check like if there is any overflow or something. Okay, cool. So let's come on to C. Polygraph is an organizer of Berlin ICPC regional event. There are any universities in Berlin number from 1 to n. Polygraph knows all competitive programmers in a region. There are n students. The I student is enrolled at a university UI and has a programming skill SI. Polygraph has to decide on the rules now, in particular the number of members in the team. Polygraph knows that if he chooses the size of the team to be some integer k, each university will send their k strongest with the highest programming skills as students in the first team, the next k strongest students in the k second team, and so on. If there are fewer than k students left, then the team cannot be formed. Note that there might be universities that send 0 teams. Okay. The strength of the region is the total skills of members of all present teams. If there are no teams present, then the strength is 0. Help Polygraph to find the strength of the region of each choice of k from 1 to n. Okay, perfect. So let's try to solve this now. So let's look at the very first example. In the very first example, we have two universities, as we can see, 1 and 2. So in the first university, we have 6, we have 3, okay, the next is 5, and one more 5. For the second university, we have skills of 8, then we have 1, and again we have 1. Okay, so Devil says she can't say because of, okay, I think that is something else. Okay, cool. So let's say if k equals to 1, that is size of every team is going to be 1. So as we can see, university 1 will actually send 4 teams, and the first team will be this 6, the second team will be this 5, the third team will be this 5, and the fourth team is going to be this 3. And from the second university, we'll have 3 teams. So this will be the first team, this will be the second team, this will be the third team. Since we are given that the universities always send the students in order, that is in decreasing order of their skills. So basically for the first team, that's why we took 6, and then we know that the second highest value is this 5, therefore we took this 5 for the second value. Okay, cool. So as you can see, all the students will be coming to the contest, so we just have to find the answer for k equals to 1. So the sum, so the sum is 6 plus 3 plus 5 plus 5 plus 8 plus 1 plus 1. So this comes out to be 10, 16, 19. Okay, so this comes out to be 29. Okay, let's come on to k equals 2. Okay, so when k equals to 2, now we know that for university 1, we'll have, in the first team we'll have 6 and 5. In the second team we'll have this 5 and this 3. Now let's come on to university 2. We know that the first team will have this 8 and this 2, this one. Now since we know that only one student is left, we cannot form a team of length 2. Therefore we just don't use this value, and the sum comes out to be 6 plus 5 plus 5 plus 3 plus 8 plus 1. This is 28. And similarly for k equals to 3. Now for k equals to 3, for the first team, for the first university, we can say that there will be only one team, and the skills will be 6, 5 and 5. And in the second university, we can say that since the size is 3 only, all the 3 will be forming one team only, and the sum is going to be 6 plus 5 plus 5 plus 8 plus 1 plus 1, and this comes out to be okay, so this comes out to be 26. Cool. And as you can see, we have the same solutions 29, 28, 26, and similarly for k equals to 4 as well. Okay, now let's look at the constraints in this. So we are given that n is actually till 10 to the power 5, and sum of all n is 10 to the power 5. Now if we see, 10 is actually the number of students, and the number of students are actually from different universities. So what we can say is the sum of this value, all the students from university 1 plus all the students from university 2 and so on, are actually going to be equals to n. So the total number of students are n. Now, okay, so we have you tried E? So no, I didn't really try E since there were very less submissions. Okay, cool. So now the very first thing that you need to notice is that, okay, so let me just remove this, is we need to sort the values, because the teams are formed on the decreasing level of skills, so sorting will be helpful. So we'll have these values as 6, 5, 5, 1, and we have 8, 1 and 1. Okay, now let's see if we had to make a team. So we know that, let's say this length is k. Okay, yeah, this length is k. Now we know that the maximum length of the team that university 1 can make is this k. Let's say this was k1. Now for this we know that the maximum length is going to be k2. Let's say for university 3 also we had some values, and this was k3. Now we know that k1 plus k2 till k7, since we have 7 universities in the very first test case, this is actually going to be equal to 7. Now since this is 7, for k1 we can actually, for university 1, we can actually first find out the value, the total sum that of the skills that university 1 is going to be sending. Then we can find out the total sum of the skills that university 1 is going to be sending if teams are of k equals to 2. Then for k equals to 3 and so on till k equals to k1. So basically the time complexity for this will be, for every k, so we are running for every k, so this will be k1 times. Now this is actually going to be equal to the time required for finding for a particular k for every university. Now, so let's see how much time we are going to take for that. So let's say we had a university and there were m students. So the count of this is m, and let's say we were making a team of size k. Now we know that, let's count the number of teams that we'll be able to make. So the number of teams would be, number of teams is actually going to be equal to m by k. Now with this we can actually see that the number of people left out is actually going to be m minus m by k times k. and this is actually equal to m percentage k, which is actually the remainder when m is divided by k. And now, who are these m percentage k people? These m percentage k people are the people with the least skill level in that particular university. Now, so all we have to do is we actually have to run a loop from the very first index till m minus m percentage k. So let's say it was 3. So we'll actually sum up the values from 1 to 3 here, leaving the fourth value behind. Or we can actually have a prefix sum. So if we have a prefix sum, this 6 will remain 6, this 5 will become 11, and this 5 will become 16. Now we can just go to array of m minus m percentage k, and it will give us 16. That is the value from the start till this index. So basically, for every k, we can actually calculate this value in O of 1. Now, so the complexity for the very first university is going to be k1, which is the length of the number of students coming from the first university. For the second university also we'll have k2, and for the third university we'll have k3. So as you can see, the total complexity will be equal to k1 plus k2 plus k3 till k7, which we already know is equals to n. Therefore, the total complexity of this algorithm is going to be O of n, which is, I hope, the desired complexity for this particular problem. So I hope the logic is clear to everybody. So what we are actually doing is we are going to every university, we are finding the count of students in that university. Then for every k, we are just checking how many people we have to exclude. We exclude the number of people, and then we find the sum of the people that we include using a prefix array. That's all. I hope it is clear. So let's write the code. Okay, or we can actually do one thing. Can people in the chat let me know if writing code is better, or if I can just show you my code and then I can explain every part of it. If that is good to everybody, I'll do that. Otherwise, I'll write the complete code. Okay. Giri says 6553. Okay. Okay. Also, if the logic is not clear to anybody, they can let me know. I'll try to explain it again. Okay, Girish says writing code, Shivam says show. Okay, I'm waiting for one more person. If someone says writing, then I'm writing. If someone says show. Okay, Swapnil says show. So I'll just show the code. You can show and explain. Okay, many people say that showing is better. Okay, cool. So I'll just open my submission only then. I'll copy the submission and I'll show you in my editor. Okay. Tushar says that it should be O of k log k since we have to sort this. Yes, exactly, Tushar. You are right. I missed that part. Okay. Writing is not visible. Krishna says, okay, I'll just increase the font. I think that will be better. Okay, cool. Okay, cool. So let's see what I'm doing here. So we have t number of test cases. So we just take t and then we have while t minus minus. Now for every test case, we have an n and we have an array of size n. So that is what I'm doing. I have an array of array n, and then I am scanning every integer into it. Now what I'm doing is I actually have a vector of size v times v of n plus 1. So I'll just show everything in the board as well. Okay. So what I'm doing is I actually have a vector of size n plus 1. So basically I have v0, v1, v2 till v of n, and these are all vectors. Okay, so the next thing that I'm doing is whenever I scan the skill of every student, I just see which university he is from, and for that particular index in the vector I push that value. So basically if you look at the test cases, okay, let me open the test case. So in the first test case, if we see, Now in the first test case, if we see, I actually got a 6, and then I checked which university he's from. I saw that he's from University 1. So all I did was I actually inserted the 6 here. Then the next value is 8, and he's from University 2. So I just put 8 here. Then again, I have 3 from University 1. So I push 3 here. Then I have 1 from University 2. So I have 1, sorry, yeah, exactly. 1 from University 2. So I write 1 here. Then I have 5 from University 1. I have 1 from University 2, and I have 5 from University 1. Okay, so we are done with the input. Now what I'm doing is, for every vector, I'm just sorting them and then reversing them. Now the reason why I'm reversing them is because sorting this vector actually gives us 3, 5, 5, 6. So I just reverse this complete vector, and the reversal becomes 6, 5, 3, 3. That is what we need, and this one remains the same, 8, 1, 1. Okay, cool. Now I have a vector, I have an array of answer n plus 1. I have initialized it to 0. Now let's come on to the main part. So for every vector I equals to 1, I less than n, I'm first making a prefix array. So okay, so I'll just write 6, 5, 5, 3, and I have 8, 1, and 1. So what this prefix array is doing is, it is converting this 6 to 6 only. This 5 becomes 11, this 5 becomes 16, and this 3 becomes 19. This 1 becomes 9, and this 1 becomes 10. Akshat says, I don't know why, but I started implementing deep in problem 2, but it was simple maths. Yes, Akshat, it was simple maths, but even if you wrote the DP, I think you would have got the same answer only. Okay, cool. Okay, so basically we are done with making the prefix in this part. Now let's come on to, so we have for j equals to 1, j less than vi dot size. So basically we know that the size of this is k1, which is actually vi dot size for me right now. Now for every I, what I'm doing is I'm actually finding out the size, that is k, percentage j, and then having that stored in temp, and then I'm just removing the values that are after it. So I just have answer j plus equals to vi. So let's say if this, we know that k1 is 4, and let's say I was 3. If I was 3, what I would have done is I would have first found 4% is 3, which is 1. Then I would have done vi dot size, that is 4, minus temp. Temp is 1, and then again minus 1. So this brings 2, and 2 is, so if we write the indexes 0, 1, 2, and 3, v1 of 2 is actually 16. And as you can see, if we are making for I equals to 3, that means we are making a team of size 3. We actually have the summation of these 3 values only, which is 16. I hope the code is also clear to everybody. And that is, so for every k, I'm actually adding it into answer j, and in the end, I'm just printing answer array. I hope this is also clear to everybody. I think this is better. I can just show the code. I think that saves a lot of time, and I can explain the code in a better way then. Okay, can everybody in the chat let me know if it is clear to everybody? Clear, sir. Vishal says clear, sir. Okay, perfect. Okay, so let's move on to problem D. Akshat says I was not able to apply iterative DB and it was showing MLE, memory limit exceeded with recursion plus memo. Oh, bhaiya, can you please discuss the iterative approach for B? I already discussed. You can just go back in the video and see the iterative approach if you want to see that. I'm sure you must be doing a very basic mistake because you are getting memory limit. That means the memory you are consuming is a lot. Okay, cool. Let's come on to problem D now. So the problem D says that you are given two integer arrays A and B of length n. You can reverse at most one subarray of the array A. Okay. Your task is to reverse such a subarray that summation of AI into BI is maximized. I thought we cannot make 2D vector of n into m. I use map to find distinct university. Hitin, that is a good idea to do that, but then since you're using a map, you have an added complexity of log of n, which is okay for this particular problem. But since we know that we can actually use a vector as well, that is better. Okay, cool. So Saurav says time complexity analysis. Okay, let's do that in a second. So let's see how much time we are consuming at every place. So this is O(n), like scanning the array. Then this is O(1), since we are just inserting the values in different vectors. Then sorting actually takes log of the size of this vi. So basically this takes v of I times log of v of I. Then the reversal actually takes size of v of I only. Then we have answer, which is nothing, and then this is all O(n) only. I think that's it for time complexity. There's not much for time complexity in this problem. Okay, cool. Okay, just a second. Cool, let's come on to problem D now. So the problem says that we're given two arrays. We have an array A and we have an array B. So let's say this is array A and this is array B. And the size of both the arrays is n. Now we need to select one subarray from this array A, reverse this subarray, and then find the summation of I equals from I equals to 1 till n ai times bi. And we need to maximize this value. Maximize. Okay. Now it is not necessary we always reverse a subarray, but if we are reversing, we just have to select one subarray. That's it. Okay, cool. So let's see what all things we can do. The very first thing that we need to notice is n is actually less than equal to 5000. So if n is 5000, the worst time complexity that we can have is n into n, which actually becomes 5000 square, which is 2.5 into 10 to the power 7, which is the worst time complexity the code will be able to run. So with this, we actually have a hint that the desired complexity for this particular problem is going to be O(n) square. Okay, cool. Hiten says worst case n log n when we have only one distinct university, right? Exactly, Hiten. Okay. Let's see. So basically the very first thing that we have to do is we have to find the answer when we do not reverse any subarray. And to do that, we just have to run a for loop from 0 to n, and we just have to multiply ai into bi and have it in a sum. That is going to be the sum that we might have without reversing. Let's consider what happens when we reverse a subarray. Let's say we had this array A. Let's say we selected this subarray. Let's say this was ax till ay. Now we had another subarray another array which was b. Let's say this, so basically this was also bx till by. Let's see the difference in the count that this reversal is going to make. So for the starting, everything is going to remain the same. So basically for the starting, we will have summation of I equals to 1 till x minus 1 will have ai times bi. Then we'll have something for this particular component that will add later, and then for the last part we'll actually have summation of I equals to y plus 1 till n ai times bi. Now if you see, when we did not reverse the subarray, this and this was constant, and the only thing that was adding was summation of I equals to x till y ai times bi. But since we are reversing, this will be removed. Now let's see what is going to be added. Now since we are going to reverse this subarray, this x is going to be ax is going to be multiplied by by. So this becomes ax times by plus ax times x plus 1, which is this value, will be multiplied by b times y minus 1, and so on till ay is multiplied by bx. I hope this is clear to everybody. Okay. Now let's see if we can actually use this somewhere. So I'll just draw this again. So we had this and this. This was ax, this was ay, this was bx, this was by. And the summation was ax into by plus a of x plus 1 times b of y minus 1 till a of y minus 1 was going to be multiplied by a of y minus 1 times b of x plus 1 plus a of y times b of y b of x. Okay, cool. Now let's see what happens when we remove the very first part and the last part. So this actually becomes a of x plus 1 into b times y minus 1 till a of y minus 1 till b of x plus 1. Now with this, what we can see is, if we just remove the last values, we can actually have the summation, the answer, if we reversed a subarray. So let's say this was m. If we reverse the subarray of length m minus 2 having the center same. Okay, Krishna says please move your pick. Okay, I think there is no need of removing the pick now, since I've already removed everything that I wrote there. I'll keep in mind this next time. Okay, so this is where DP comes. So if we have an answer of, let's say, for x and y, we can just say that this answer of x and y is going to be a of x b of y plus b of x a of y plus answer of x plus 1 comma y minus 1. Is this clear to everybody? Okay, clear. Okay, so what we can have here is, we can see here, so for answer xy, we need answer x plus 1 y minus 1. For x plus 1 y minus 1, we'll need x plus 2 y minus 2, and so on till x is equals to y, since because at that point we'll have an array of length 1, or x is less than, x becomes greater than y. Let's see, so now let's see how many x and y we can have. So L can be from 1 to n, and R can be from L to n, because R will be always greater than L. And so basically with this, we can actually say that the complexity for this is going to be n times n, because there are n values for L, and for every value of L, we might have at most n values. So the total complexity for this is going to be n into n. And now since we know that for every iteration, we just have to find the answer for another iteration. So basically, and in the worst case, when x equals to y, we can just say ax into bx, because x and y are equal, and this is O of 1. So the total complexity becomes O of n square. Is this clear to everybody? Okay, Hiten says, can you explain again? Okay, I'll just explain the DP part again. So let's say we had a subarray for this x. Okay, just a second. Let's say this was A. Let's say this was B. And let's say this was X and this was Y. So this will be AX. This will be A of X plus 1 till A of Y minus 1 and B of Y. Now for A of Y. Now for this array, we'll have Bx, we'll have B of X plus 1, we'll have B of Y minus 1, and we'll have B of Y. Now let's see what is the summation of the products. So the summation of the products come out to be AX will be multiplied by BY. So we have AX and BY. Then we have A of X plus 1 will be multiplied by B of Y minus 1. So we have A of X plus 1 multiplied by B of Y minus 1. And in the similar way, we'll have for A of Y minus 1 will be multiplied by B of X plus 1. We'll have A of Y multiplied by B of X. So we'll have plus A of Y times B of X. Now if you see, what happens if we remove AX, BY and AY, BX? This actually comes out to be the answer for the summation when we consider the arrays as x plus 1 till y minus 1. Because for x plus 1, we'll have A of x plus 1 into B of y minus 1. Then we'll have A of x plus 2 multiplied by B of y minus 2, and so on till A of y minus 1 multiplied by B of x plus 1, which is this. So what we can say with this is, the answer for A of x comma y is actually equal to A of xy plus B of x A of y plus answer of x plus 1 comma y minus 1. And this is how the DP for this is going to run. So this is basically recursion, but as we can see, we'll have multiple subproblems here which will be overlapping, so we'll just have DP for memorization. I hope this is clear, and most of the things will become clear when I show you the code for this. I'll do the same thing only. I'll just have the code I'll show the code to everybody so that everything is clear. Okay, cool. Okay, let's forget the main part of this and let's see what I'm doing for solve LNR. So what this is actually, so let's say if we are doing the code the right way. So basically for solve, if I have a call for solve L comma R, I first have a the very basic conditions, which are if L is greater than 0 R, that means this X has become greater than Y, and if this X is greater than Y, we know that the answer is going to be 0, because that is not possible. If L is equals to R, that means we are actually at the same index, and for that we just have to multiply the same values only. So we'll have AL into BR. Then if this state is already covered, then we just have to return the value at this state. Otherwise, what we are doing, let's see what we're doing. So we have A into L into B into R plus A into R plus B into L plus solve for L plus 1 comma R minus 1, and that is exactly what we wrote here. So we just take the terminal nodes, we multiply them, we have the values here, and then we just call for a size less than for a smaller array. That's it. Now let's come on to the main part. So what am I doing here? So the very first thing that I'm doing is I'm actually having an answer which is when we do not have any sub arrays reversed. So for that, everything will be AI into BI. So I have the final answer in this answer. Now let's see what I'm doing with prefix. So basically I had A0 B0 plus A1 B1 plus A2 B2 till A of n minus 1 B of n minus 1. Now what I did was I actually made a prefix array of this. Now the reason is because whenever I have to find the value for x and y, so let's say I had to find, let's say this was A, and so this is x, y, x, y. This is A, this is B. Now I know that I'm going to be reversing this array of length from x and y, this array from A from x to y. So what is my final answer? My final answer is actually going to be, this is A1, this is B1, the last value is AX minus 1, this is B of x minus 1, this is A of y plus 1 till A of n minus 1, here we have B of y plus 1 till A of n minus 1. So basically for the starting part, the summation is actually going to be summation of I equals to 0 till x minus 1 AI times BI plus the DP part. So the DP we are actually using solve. So we'll have solve from x to y, and then we'll have summation of I equals to y plus 1 till n minus 1 for AI times B of I. Now to calculate this, there is one way that we can actually run a for loop, but that will consume some time. So what I'm doing is I actually have the summation of all the values from the first index, from the second index till A of x minus 1. So this is nothing but prefix of x minus 1. Now let's see how to find the summation for this particular array. So this component. So for this, all we have to do is prefix of n minus 1. So this is actually containing the sum of, so this is actually equals to answer also, the starting initial answer that we found, because it has the summation of all the products. And now we'll just subtract the values for the summation till this point, which is actually prefix of y. And that is exactly what I'm doing. So what I have is I actually called it for DP. I have the value of solve ij. Now what I'm doing is I have prefix of n minus 1, which is prefix of n minus 1, and I'm subtracted prefix of j, which is prefix of y here. Then if I is greater than 0, I just have prefix of I minus 1 added into this temp. Then I'm adding temp of dpij, which is actually the solve xy, and then I just check if the new answer is greater than the previous answer. If it is greater, then I just have this answer stored here. Okay, so we have cout answer. Okay, Giri says we are diagonally filling up our DP array, right? Yes, we can say that. If this was an iterative approach, I could have shown you how we are doing it diagonally. But in recursive also we are doing it diagonally only, but we're just coming from top to bottom. Instead of going from bottom to down, we are coming from top to bottom. Okay. So that's it for this particular problem as well. Can I have a clear from everybody in the chat so that I know people understood this problem as well? This was a very basic problem, I would say. So if you do like 3-4 problems like this, I think you'll all be able to do this in the contest as well. This is a very standard way of solving these questions. Okay. The answer is clear. Perfect. Okay, so I'll have this here. Okay, can people in the chat also tell me their ranks as well if they're interested in telling me how much rank they got today, so that I can see the majority of the people that I'm teaching today. Okay, Girish says share similar problems. To look into the similar problems like this, you can actually go to CodeChef as well. You can just look for problems which are related to DP. You can also look into the problem set of Codeforces and just look for the tag DP, and you'll find many problems like this. Otherwise, you can just go to lead code as well. There are many problems in DP. So if you just open up the problem set for DP in lead code, there are like all problems are actually similar to this only. Okay. Greece is losing Saturday. That's not an issue if you have just started or haven't put much time into CP. I think that's okay. Just keep practicing and you'll get better. Okay. I think that's it for this stream. The next contest is global round. It's on. Let's see when it's on. So the global round is on 2nd May. So we'll have 2nd May is I think Sunday. Yes. So we'll have the next stream on Sunday. Then we have on 4th and 7th. So there are many streams coming. We'll also be absolving the lunchtime also for the next month. Is CSCS good for learning DP? Yes, it's good. I've heard it's good. I personally haven't done any problems in CSCS, but I plan to do them someday. But yes, CSCS is definitely good. You can obviously go for it. Okay, I think I'm gonna end the stream now. That's it for